Hello, welcome back to the channel. So let's move on to a new unit which is based on improper integrals. So in this video, we will learn when an integral is known as an improper integral. So in this question, you have to identify for which values of b is this integral over here, is this definite integral improper. So there are basically two reasons when your definite integral can be an improper integral. The first reason is when one of your limits is not a real number. So what we mean by one of the limits not being a real number, for example, in this case, since we are calculating the definite integral of this expression from 0 to b, if in this case our b is either infinity or if b is either minus infinity, we know that both of these values are not real numbers, right? So if our b value is plus infinity or minus infinity, this integral would be an improper integral in this case, in the cases of b being plus infinity and minus infinity. So this is the first case, the first reason why a definite integral can be improper. And the second reason is, which is more important than the first one, so you know that whenever you calculate a definite integral, for example, in this case, if you're calculating the definite integral of this expression, you're basically calculating the area under the curve of this function from x equals 0 to x equals b, right? So you know that in this case, your x is basically varying from 0 to b, right? And you're basically calculating the area under the curve of this function based on all the x values which lie in between 0 and b, right? So in this case, a definite integral is said to be an improper integral if the domain of integration, the x values or the values which you are varying in the definite integral, if this interval, the domain of the integration, contains any point which has a discontinuity. So basically, if in this interval our x value contains any point where the domain of the function is not defined, domain of this function is not defined, we will call it an improper integral. So in this case, since we are calculating the definite integral of 1 upon x square minus 1, we know that the domain of this function does not contain plus minus 1, right? So if our domain of this integration, if the interval for which we are calculating the definite integral for contains one of these points in the interval, that integral would be an improper integral. So for example, you know that in the interval you don't want a point which contains x equals plus minus 1. So the first case is if your b is greater than or equal to 1, you know that your integral in this case, your definite integral in this case, would be calculating the area under the curve of this function from x equals 0 to x equals b, where your b is greater than or equal to 1, and you know that if your interval, if the domain of your integration contains one point which has a discontinuity, your integral is an improper integral, right? So in this case, if your b is greater than or equal to 1, let's suppose if your b is equal to 2 in this case, you know that you will be calculating the area under the curve from x equals 0 to x equals 2 in this case, right? And since in this case the domain of the integration contains 1 in it for which your function is not defined, that would be the case when you will say that your definite integral is an improper integral. And similarly is the case with x equals minus 1. If your b in this case, if your b in this case is less than or equal to minus 1, so if you're going on the left hand side before minus 1, you'll be basically calculating the area under the curve from 0 to a b point which is less than or equal to minus 1. You know that if you're calculating the integral from 0 to b where your b is less than or equal to minus 1, you'll pass by the x equals minus 1 point as well, right? And you know that again, since in this case x equals minus 1 is not defined for this function, so that integral will be an improper integral. So if we have to summarize the concept of improper integrals, a definite integral is said to be an improper integral because of two reasons. The first reason is when one of your endpoints is not a real number, you'll call your integral as an improper integral. And the second case is when your domain of the integration, the interval of your integration, contains a point for which your function has a discontinuity at that point, you will call it as an improper integral again. And you can also clearly notice in the solution to this problem as well, you can see the graph of 1 upon x square minus 1, and you can clearly see that why the values of b in between minus 1 and 1 not included. It's easy for us to calculate the definite integral for this interval over here, which is from minus 1 to 1, right? But if we have those values, for example, for b to be greater than or equal to 1, we'll have to pass by this point over here, right? And calculating the area under the curve, if we pass by this point, would not be a proper solution to the definite integral, right? So that is why, in this case, our integral is said to be a proper integral when our values of b lie in between minus 1 and 1 not included. But our integral is an improper integral when our b is greater than or equal to 1. So you're going beyond this 1 point. Or if your value of b is less than or equal to 1, which means you're going to the left of this point and to the point where your function is discontinuous, right? So that's it for this video. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.